Welcome to Calculus.
Our stress tolerance level has risen so high that nothing phases us.
On this episode, Stevenson will demonstrate
find the absolute extreme of h of x equals natural log of x plus 1 on the interval from 0 to 3, on the closed interval from 0 to 3. Okay, first things first, does extreme value theorem apply? Well, I know I have a closed interval, so now what we have to see is this function going to be continuous on this interval? Let's do a sketch. We can use parent functions to do this. Now, transformation-wise, since it's plus 1, what that means is this function has moved to the left 1 unit. So let's think about this. This thing will now be continuous. This domain is from -1 to positive infinity. This piece is only from 0 to 3. So 0 is here, and we'll just say 3 is there. So this is the piece they're looking at right there. That's the 0 to 3 piece. That piece will be continuous on this closed interval. So we do know now that EVT applies. Okay, now we're going to use the derivative. We're going to find it and then use that to find critical points. From here, we need to consider where our critical points are. First question, when does the derivative equal 0? Well, we can set this equal to 0 and solve. Now, when does this not exist? Well, this is a rational function. Again, we can use our parent functions. If I cover up this one, this is just the reciprocal function 1 over x. But because it's being shifted to the left 1 unit, that means it will look like this. So this is h prime. So when will it equal 0? Never. None. And when will it not exist? It will not exist at -1. Okay, before we make our table of values now, let's test. We have critical points. Do any of these need to be excluded? In other words, check these against the original interval. So this had none, but this had -1. -1 is not in my interval. That means I can throw this out. So what this means for my table of values is I will only have the endpoints in my table of values. Next, I'm going to take these two x points, plug them into my original function, and solve. From here I can see that when x is 0, I will get my absolute minimum of 0. And when x is 3, I'll get my absolute max of 4. So let's answer the question.